move on. Hey, did you guys get the remind message yesterday? Awesome. And I'll keep sending those out. If you ever try to watch the video and there's no sound, send me a message. I've had trouble with my headset some last year where some days the sound worked and some days it didn't. So if you ever at home trying to watch the video and there's no sound, text me because I can send you another video even from like last year that you can use. I hope. We're getting ready to see. It worked first hour though, but it did yesterday too. So who knows? Okay, and so we talked about this, and we were talking about intersections when we left off, right? And about how last year in Algebra 1, you guys solved systems of equations. All right, so what we didn't really get into, and this was obvious last night with several of you sending me messages about problem number 3 on the core math page. So if you got that far and you were looking at it, I had several questions about it, so you were not alone. Intersections in geometry, we are not going to be looking at those in terms of an ordered pair like you did in Algebra 1. When two lines intersect, you're looking for that ordered pair. We're going to talk about it in terms of our geometry terms. So when two lines intersect, they intersect at what? A point. And so we're looking for those geometry words. When a plane intersects another plane, where do those two planes intersect? At a line. They're going to intersect at all of those points where they meet, right? Where do three planes intersect? At a point. So three planes can intersect at a point. They could technically, three planes could intersect at a line depending on how they are. You could have three different pieces of paper all intersecting at a line. Maybe I can illustrate a little better here. So if I had these two intersecting, and then if you'll put a third paper in the middle there, do you see how they could intersect at a line? Okay, so they could intersect at a line. They could also intersect at a point. You're going to be thinking about describing things that way. So on number 3, it's talking to you about using your pencil on your paper. And when you're writing on your paper, describe the relationship between your paper and your pencil. What's happening with your pencil and your paper? They intersect, and they intersect at what? A point. And it even names the line segment, so you could even name what point that is based on whichever endpoint you want to use on that line segment. So that's what they're looking for. Use your descriptive words from our vocabulary for geometry. Okay? So think about it not in terms of algebra and numbers. Think about it in terms of what's my geometry word, where do they intersect? And that leads us to our last two postulates from 1-1. If two lines intersect, how many times are they going to intersect if they're two different lines? Once, at one point. The only way they can intersect at infinitely many points is if they are the same line. So if they say two lines intersect, they are always going to intersect at exactly 1 point. And with two planes are always going to intersect at one line. Okay, just like the two walls when they come together. And again, I really feel like those postulates are kind of common sense if you just think about the actual picture. It's not really hard. And you do not have to memorize those word for word. You just need to know that that is true. Okay, we're going to start drawing three-dimensional figures, and when we draw them, you have got to have a way to show that they're three-dimensional. And to do that, you're going to use those dashed lines. Those dashed lines are going to bring in that third dimension. So anytime you're trying to show a third dimension, you need to use a dashed line. Or if you're, so let me give you an example. Let's say that my pencil is going through this paper. So it's not in the plane, it's going through the plane, like this, right? So you can see part of the pencil right now, right? But you can't see the other part behind it. The part you can't see is still there. You need to use dashed lines to show that it's going through the plane. So if I want to draw a plane, I'm going to draw a parallelogram. That's typically what we'll use when we're talking about a plane. Okay, so you'll just draw a parallelogram to indicate a flat surface. And then if you want to show that you have a line in your plane, you'll just draw a solid line. The line is in your plane. That means I have this pencil. It's not going through it. It's laying on top of my paper. It's in my plane. But if you want to show that it's going through your plane when you draw it, you're going to draw your line with arrows on the ends. And at some point when that pencil goes through the paper, that line's going to stop being solid and it's going to start being dashed. But then once it comes out of the plane and you can see it again, so if my pencil were long enough, eventually it would go through the plane and you would start to see it underneath my plane again, right? So then that part will be solid again. And that dashed line helps you see that third dimension, and now you know that it's not in the plane, it's going through the plane, and it intersects at this point S. Is that making sense? You use 3 dimensions also when you're drawing things like a cube, which we're actually going to learn another name for later. But when you draw a cube, you're going to want to use those dashed lines for the parts that you can't see. Okay, to help give it that third dimension. And it takes practice, and here's the best way you can draw your shapes if you're having trouble. Any pictures, look in your book. If you'll look through the section, they have awesome pictures in there, and you may even can just trace to get an idea and create whatever it is you're trying to create. So I would flip through my book if you're having any trouble at all with drawing something. Okay, so you and your partner, go ahead and answer the next 2 questions. Once you get those 2 done, go over to the right and do the last one. So these 2. Good. And when we're working in here, guys, I know that some of you are in pairs, some of you are all by yourself. If you and your partner are having trouble, don't hesitate. Turn around behind you, ask the people behind you, or tap on the people in front of you. Compare answers while I'm giving you time to work, and then we're going to check them. If it's in it, that means it's lying on the plane. If this is not through. If it says it intersects, then that means it's going through the plane. Going to give you just another few seconds. Okay, let's go back up here and let's check and see how you did. Part A should have been pretty easy. You're just drawing 2 lines that intersect, so it should have looked something like that. You can put points on them if you want to, and that way you can actually name the lines if you needed to, but it didn't tell you to do that, so that's totally fine. Part B says sketch a figure that shows a line that lies in a plane. That means it's not going through the plane, it's just in the plane, so everything should be solid. Just a plane with a line in it. Make sure you're putting arrows on the ends of your lines. If they don't mean line, they'll say segment. So make sure I'll be picky about that. Any questions on the first 2? All right, and then the last one, it wants you to sketch a figure that shows 2 lines that intersect, and they intersect in 1 point, and that 1 point is in the plane. But only one of the lines is in the plane. So the first thing you would need to do is draw yourself a plane. How many lines are in the plane? 1, so I would draw a line in the plane somewhere. That means it's solid, it's in that plane. And then you need a second line that's going to intersect this line at 1 point, and that 1 point is in the plane. So somewhere draw a line that crosses it, but oops, sorry, just kidding. Don't do that. It's not going to let me erase. It's going to work today, but not erase. Okay, start over. There. So line in the plane, and then a line that intersects, but once it intersects, you've got to use some dashes to show that it's going through that plane. Comes back out, solid. Questions? Is this making sense? Awesome. All right, that's 1-1. We're going to shift to 1-2. And here's what we're going to do today, guys. I was tough on you first day giving you homework. Would you agree? Well, that's nice. Good. Good. I know. So I wanted you to realize day 1, if you're going to double block, you've asked for a lot and you're going to have homework. But we got a little bit behind going and getting textbooks and doing all of those things. So we're going to finish up 1-2 today, and then I'm going to give you your assignment. We're not going to go on to 1-3 today. We'll pick up 1-3 tomorrow and maybe start 1-4. So we're going to get off a little bit from what I had up here planned, but that's okay. So you'll have the homework I gave you last night to work on, but we're not going to get another assignment today. So we'll go through 1-2 notes, then I'm going to give you the rest of the time period to start working on that homework, and then we'll pick up with 1-3 tomorrow. Is that good? Okay. And if you've already got the 1-1 and 1-2 done, then you can check answers and make sure that you have them all correct. Okay, so let's go to 1-2. Maybe. Here we go. All right, so 1-2. It's talking about midpoints, and we are not necessarily, we'll see if we have time for constructions, but we will do constructions in here. So if you haven't gotten to the SOAR yet and you don't have a compass or a protractor, make sure that that's on your agenda as soon as you can, because you are going to start to have some constructions you're going to need to work with eventually, but you can wait till this weekend and you'll be fine with that. Lots of vocabulary, again in 1-2. We'll start with what is a coordinate. And you know coordinates from Algebra 1 as being something like this, right? But we're talking just about one coordinate. So we're going to start off real basic in 1-2, and we're talking about a number line. And a coordinate is just simply the number that corresponds to a point on a number line. So for example, what would be the coordinate for point A? 1, okay? So we're going to start out in 1 dimension, and then we'll build to 2 dimensions and talk about what you learned in Algebra 1. So a point corresponds to one and only one number. Every point is infinitely small and has one number associated with it. There is a point right next to point A that is at 1.0000001, really close to it. The ruler postulate, don't worry about trying to memorize that. It's really not something that we'll use a lot. There are a lot of postulates and theorems I am going to make you memorize the names for, but this is not one of them. The ruler postulate, just one more time, indicates that for every single point on the ruler, there is a specific number that corresponds to it, so that you can identify what point you're talking about with a number. So we're going to start with really simple distance. When we get to 1-6, we're going to talk about 2-dimensional distance. This is 1-dimensional distance today, basic math. Did I talk to you guys about the distance and midpoint formulas that we're going to learn later? Okay, so I will go ahead and tell you today, when we get to section 1-6, we're going to learn 2 formulas, the distance and the midpoint formula. And I'm a firm believer that if you put things to music, you tend to remember it better. How many of you learned the quadratic formula? To pop goes the weasel? All right. Oh, well, maybe we should sing it for you. Uh-huh. She did? That's awesome. Well, here's what I'm going to offer for you. When we get to distance and midpoint formula next week, we are going to memorize them, and we're going to learn them to 2 songs. One of them is On Top of Old Smoky, which a lot of students aren't real familiar with, but it is, if you think about it, as the version, something spaghetti, on top of my spaghetti, meatballs, some song like that. How does it go? Do you know it? Okay, well, I'll play it for you when we get there. They make another little fun version, but it's the same tune as to On Top of Old Smoky. It's really slow, and then we're going to learn the other formula to the Itsy Bitsy Spider, which you're probably a little more familiar with. I'm going to give you an opportunity when we learn those to earn 2 homework passes. Remember, we talked about the homework passes. Okay? So if you memorize the song and get up in front of the class and sing it, then you will earn a homework pass for each formula. So there's a chance to earn 2 homework passes. Okay? Hold on, let me explain and see if this answers your question. You can either memorize it to the tunes that we're going to sing it together, or if you're creative, you can go home and create a rap, bring your instrument. You have to be able to sing it, so you can't like play the flute while you're doing it. But if you want to bring a guitar, whatever, you have to sing it. And you have to know the words. You have to have it memorized. You can do it in pairs. So if it helps to have a buddy, here's the only thing. You and your buddy both have to know it. So one of you can't carry the other one while their mouth is like stumbling over every word. If I can't hear both of you singing it, then I'm going to make you start over, and then eventually the person who doesn't know it's going to have to sit down. So make sure you know the words, okay? But you can be creative, or you can use what we do in class, and we'll sing it together. It's not mandatory. Don't go home in tears telling your parents you have to sing in front of the class. You don't. McKinney. 2. Only 2. Now, you could choose to get with Miranda, sing up here, and then you could choose to get with Beatrice and sing up here again, but you still only get 1 card for each song. But if you want to be that friend that says, yeah, I'll sing it with you twice, I know it, I'm cool, I got it, then that's fine. Okay?
If we just memorize it, but don't sing it.
Nope. No. So you have to memorize it to music. Your choice or my choice does not matter, but you have to be brave enough to be in front of the class and sing. Okay?
If we only do 1.
Then you get 1 homework pass.
Oh, yeah.
1 for each one, okay? So, and there'll be some things like that that I just kind of sporadically throw up, or throw out there, not throw up. So that is going to be next week. We'll learn them. It'll probably be the following week. We'll have to see where it paces out that you actually get up and sing it. It may be towards the end of next week. We'll see. Yes, be great. Sure. All right, so that distance formula, though, is going to be 2-dimensional distance. We're not two-dimensional distance. We're not talking about a coordinate plane, x, y. We're talking number line, 1-dimension distance. So in other words, if I had a point at A and a point at B, what's the distance from A to B? 2, okay? Very simple. 1, 2. Sometimes they're not going to be really simple numbers, though. It could be that this is 1,462 and this is 3,500,000, I don't know, whatever, 572,352, I don't know. It could be a large number, okay? You're not going to want to sit there and count all the little tick marks until you get there. So the distance definition is between any 2 points. If you want to find the distance on a number line, it is the absolute value, because distance is never negative. It is the absolute value of the difference, which means subtract, of the 2 coordinates. So you could say the distance from A to B is equal to the absolute value of 1 minus 3. What's 1 minus 3?
2.
And the absolute, oh, hold on. What's 1 minus 3? Negative 2. And the absolute value makes it positive 2, okay? When you use notation, and again, this right here is probably the number 1 thing I count off for all semester long. So listen carefully. What does this mean from yesterday? It's a segment. What does this mean? It's array. New today, if you see 2 capital letters side by side, no comma, but there's nothing up above them, that means distance, which is a number. So if you see 2 capital letters side by side, it's not a segment, not array, not a line, nothing is above it, it means find the distance from A to B. Are you with me? You do not put a line segment above it if you're telling me what it's equal to. If you're telling me the distance from A to B is 2, there should not be a line segment above it. Here's why students get confused. In the book, they'll say, find the length of AB. And so they think, oh, AB equals 2. Because they put a line segment here. They're telling you to find the length of the line segment. And then you're going to tell me the distance from A to B is 2. Does that make sense? Distance is a number. A line segment is a shape. So be really, really careful. So that's why I'm pointing that out here. It's called the length of AB, or the distance from A to B. Okay? And you can just subtract them, and the order won't matter because you're taking the absolute value anyway, so it's always going to end up positive. Any questions? All right. Simple math. So these should be pretty simple. We'll just do them together. What's the distance from B to C? Careful, distance will never be negative. Yeah, so it'll be negative, and then you take that absolute value, and it makes it positive. And if it's really simple like this, I'm not going to expect that you have to show the work of subtracting and taking the absolute value. But if the numbers are bigger, then you'll need to show that work, okay? If it's really simple, you can just count, and that's okay. What's the distance from A to C? 5. And again, you could do absolute value of -2 minus 3. And what's -2 minus 3? -5. +5 is our answer. Are we good? This also helps those students that in Algebra 1 always got confused about if they counted where they started or not. You don't count where you start, you count the distance. So 1 unit, 2 units. All right. Go ahead and you and your partner answer those. Okay, what did you get for x to y? Go ahead, McKinney. What did you get? 4.5. X to y is 4.5. Is it 4.5? Okay, x to y starts at 1.5 and only goes to 5. So if we do 1.5 minus 5, 5 take away 1 already leaves you with 4. Take away another half. That's 3.5, right? And then the absolute value makes it +3.5. Does that make sense? Okay. What about x to z? Remind me your name. Yes. Molly. Okay, Molly, what's x to z? 4.5. So we're going -3 minus +1.5. So that's going to give us -4.5, and then absolute value gives us +4.5. Any questions? All right. The next thing we're going to talk about are tick marks. Tick marks are going to be used to show you that things are congruent. What does congruent mean? Congruent means that they have the same measure. So we're going to have congruent segments. Congruent segments are simply segments that have the same length or the same measure. If things are congruent, they're going to put tick marks on them or different sets of tick marks if they're not congruent. So you may see 2 line segments drawn that have different lengths, and they may put different numbers of marks to indicate that they are not congruent. One thing I want to warn you about overall this whole semester is you are not to assume that things are drawn to scale. It may look like it is congruent, and then it turns out that it is not. It may look like it's not congruent, turns out that it is. It may look like a 30-degree angle, and it turns out to be a 150-degree angle. They will purposely draw things not to scale in order to check to see if you're doing the math correctly. So don't ever assume anything is drawn to scale. Tick marks indicate that they are congruent. Congruent means they have the same length. Here's the second thing that I count off for all the time. Students mess up with. We just said if you have 2 letters side by side with nothing above them, what does it mean? Distance. Distances could be equal. So if you are using correct notation, you would say PQ, the distance, equals RS, the distance. The word congruent has a different symbol. It's not an equal symbol. Congruent means that they have the same length, but you're going to use an equal sign with a little squiggly above it. Okay? So equal sign with a little squiggly. It's probably a little better like that. That means congruent. Segments are congruent. So instead of saying PQ is congruent to RS with no line segment, you're going to say segment PQ is congruent to segment RS. Super picky notation. If it's a distance, it's a number, they're equal. If it's a shape, like a line segment, they're congruent. Okay? Shapes are congruent, numbers are equal. So be very careful. I will circle that on your homework for a while if you're doing it wrong, but then on the test it's going to start counting off. So I'll try to remind you, but it will cost you points. So be careful. Constructions, we are going to do several constructions this semester. A construction is a way to create a figure that is more precise. When you do a construction, you are only going to use two tools in here, and that is a compass, which remember is the thing that makes circles, and a straight edge, not a ruler. Now I'm not going to go out and buy blank rulers that are actually called straight edges for our class, because that's just a waste of money. We're going to use a ruler just for the straight edge part, but a construction never measures things with the tick marks on your ruler. A construction does everything with the compass doing all of the measuring. And I'll know that you didn't just use your ruler because your compass is going to have arc marks when you create your pictures, and I'll see those arc marks. And if you're missing those arc marks, then that means you didn't create it with the compass. You did it with the ruler. So we are going to do several constructions throughout the entire chapter. Okay. This definition's kind of silly, the word between. They want to make sure that you understand that between does not mean midpoint. I can say, I'm going to cheat. Ridley. I can say that Ridley is between myself and Miranda. But is Ridley at the midpoint between me and Miranda? No. She is between us. There is a line that could be drawn that would connect all three of us, but she's not in the middle. So when you see that word between, that does not mean midpoint. Okay, so be really careful. So in order for you to say that point B is between 2 points, A and C, so if I'm A, Miranda's C, Ridley's B, then that means there has to be a line that would connect us if B is between us. This leads us to our very first and one of the most important postulates we're going to learn. You will need to memorize the name, segment addition postulate, and know what it says. Because when we get to proofs, you're going to use it a lot. Segment addition postulate. And it's really basic common sense what it says. It says if you have a line segment and there is a point on that line segment between the two endpoints, then part of the line segment, AB, plus the other part of the line segment, BC, should equal the whole thing, AC. So the simple way to say it is part plus part should equal the whole. Okay, very simple in the concept, but you're going to have to be able to write it with the algebra expression. So if they ask you on the homework to create a picture of a segment and state the segment addition postulate, that just means draw a line segment, label it whatever it tells you, and then write the segment addition postulate. DE plus EF should equal DF. Part plus part should equal the whole. Does that make sense? Okay, and then we're going to apply that to with some actual algebra. We'll start with simple numbers here. I'm going to set it up harder than what it probably needs to be when you actually do your homework so that it works for the next one. So if G is between F and H, what are the two endpoints? F and H. So you could draw yourself a picture. F and H. Where is G? Anywhere in between. Does not matter. It could be middle. It could not be the middle. We don't know. They tell you FG is 6. I would encourage you to draw a picture and label your picture. So the distance from F to G is 6. And then FH is 11, which is the whole distance. The question is, what's the distance from G to H? So what would be the distance from G to H? 5. And in your head, you just did 11 minus 6, right? You could, you do not have to, you could write it out, call this GH, and say 6 plus GH should equal 11. And then that tells you to subtract 6 to solve for GH, if you're confused. But you could just do that mental math and say it's got to be 5. Does that make sense? Okay, they're going to get harder. They're going to throw in some algebra. Here's an example where we have algebra. So now M is between N and O, and they want you to find NO. So let's start with our segment addition postulate. What could I write down based on this picture? 17 is MN, okay. What else? Say it again. Who's talking? MO is 3x minus 5. What else is in our picture? NO is 5x plus 2. So using our segment addition postulate, what could I write down as an equation? Go ahead, Molly. So we just said the segment addition postulate states part plus part equals the whole. So that means that NM plus MO should equal NO. So you could start with it in terms of the actual letters, or you could start by just writing this equation. I don't care. And then show your work. So let's do our algebra. What could I do on the left-hand side here to make it simpler? So I have 17 and negative 5, right? So what's 17 minus 5? 12. So I'm going to have 12 plus 3x equals 5x plus 2. What do we want to do from there? Can subtract the 2 from both sides. So now I have 10 plus 3x equals 5x. From here, subtract the 3x. And now I have 10 equals 2x. Divide by 2. What is x? Is that what it asked me to solve for? No. Now I have to go back and plug it in. Wanted me to find NO. I found out that x was 5. So NO is the whole thing, which means I'm going to plug in that 5 for x. So now I have 5 times 5 plus 2, 27. Remember, when you write your answer, you will not put a line segment above NO because you're telling me the distance, and distances are numbers. Shapes have line segments. Okay? Are we good? Now, they may ask you to find all of them. They may say find MO and NO and NM, and then you have to list them all. We will practice our algebra a lot in here. Oops, went too far. Okay, next one. Oops, just kidding. Next definition is midpoint. So midpoint does mean that it is directly in the middle. We are not going to use that as its definition. It is super important that you know the real definition for midpoint, and I'm thinking about when we get to proofs. The hardest part of proofs, when people say they're hard, is not that proofs are hard. Why proofs become hard for people is because they don't know their definitions, and they don't know their postulates, and they don't know what we're going to learn later are called theorems. You're going to have to memorize your postulates, your theorems, your definitions, and if you know those, proofs become really easy because it's just going to be, how do I get from step A to step D? And you're going to have to list the way to get there. The way you get there is pretty easy for people, but it's the why you can do that that becomes hard. And so the why is your definition, your theorem, your postulate. And so if you'll memorize these as we go, it'll make proofs become so much easier when we get there. So midpoint definition. A midpoint is a point that bisects. We'll talk about what bisects means. Or divides is another word for bisect. Midpoint is the point that bisects or divides a segment into two congruent segments. So a midpoint divides a segment into two congruent segments. Bisect means to divide into two congruent segments. So it's the same idea. Midpoint is the point. Bisect is the action, splitting it into two congruent parts. So if I have a line segment, AB, my midpoint M is going to split this line segment into two congruent parts. And I can use little tick marks to show that they're congruent. Okay? So what's that going to mean about the distance from A to M and the distance from M to B? They'll be the same, so they'll be equal, right? Distances are equal. The line segments themselves, AM with a line segment and MB with a line segment, those are going to be what? Congruent. Again, pointing out that notation. Are we good with that picky notation? Segments are congruent, distances are equal. And I'm going to say it a bunch because it's the thing I usually see the mistake on. So if you look at, do you guys have a picture on yours that's missing on mine? No? Okay. So if you have a line segment AB, and M is in the middle, if this whole thing is 6, that means this piece is 3, and this piece is 3, is what they're saying here with this sentence. Your midpoint's going to split your line segment into 2 congruent parts. Okay, I'm going to skip this next example, and I'm going to come back to it at the end. So skip this one for now, and this one, and let's go on to this one. So find this example in your notes. Sit on the back. Okay. So it says D is the midpoint of line segment EF. They give us what ED is, and they give us what DF is, and they label the picture. If you don't have a picture on your homework, you may want to draw yourself a picture and label it before you start. They want you to find the distance from E to D, D to F, and E to F. What are we going to do here? Okay, what could our equation be? Okay, that would be an expression because you don't have what to set it equal to. If you just write down this part plus this part, then you have to know what the whole thing is so that you have something to set it equal to, so you have something to solve. The problem with this one is they don't tell us the whole, right? But it goes back to this word midpoint. So, Batris? Exactly. So watch what they're telling you in the problem. If D is the midpoint, then we just learned that means that the parts are now equal. So you don't have to do segment addition postulate, part plus part equals whole, because you don't know the whole, first of all, and they're just equal to each other. So now you can do 4x plus 6 equals 7x minus 9. But only if it's the midpoint. If it's not the midpoint, it's just the word between, that won't work. Okay, what do we do from here? Add 9. So now we have 4x plus 15 equals 7x. Subtract 7x. You could subtract 7x, but then you're going to put that x over with your number and have a 0, so it may be a little easier to subtract the 4x. So now we have 15 equals 3x, and then what? Divide by 3, so what is x? 5. Is that what our answer is? No. Be careful that you're going far enough and that you don't go too far. So they want you to find ED. Remember, that's a distance, no line segment. They want you to find DF, and they want you to find EF, the whole thing. So you're going to plug that 5 back in. What is 4 times 5 plus 6? 26. What is, do we really need to plug it back in over here? No, because what did we just say about ED and DF? They're the same, so you could just say this one's 26. If you want to check it and make sure you did your math correctly, you could. But 7 times 5 is 35, minus 9 is 26. And then to get the whole thing, what are we going to do? Add them together, so it is 52. Circle your answer. Make sure you show your work. Any questions on midpoint? Okay? If I go too fast, slow me down, okay? Oops, I went too far. Okay, so now I want you to go back to the problem that we skipped. Oops, wrong slide. Go back to the word problem. Let me pull this back up. Okay, go back to the way back here. Come on. Okay, so this problem, I'm going to give you a few minutes. Just kidding. I think I've pushed it so many times now, it's like trying to catch up. Okay, you know where I'm talking about. Find the problem on your page that says something about the checkpoints. Uh-huh. Okay, so, oops, that's not what I want to do. The map shows the route for a race. You and your partner see if you can answer that question. There, just to make sure that you've done it correctly and shown work. So when you're getting a big word problem like this, always dissect it sentence by sentence and start drawing a picture and labeling your picture. It's going to help you so much. So the map shows the route for the race. You're at X, which is 6,000 feet from the first checkpoint C. So C is your first checkpoint, and X to C is 6,000 feet, right? The second checkpoint is at D. So this is your second checkpoint. And D is located at the midpoint between C and the end of the race Y. So what did that tell you if D was the midpoint? Very good. That CD and DY were congruent. So you could put those little tick marks to tell yourself these two distances are going to be the same. The total race, which went from X all the way to Y, was 3 miles. And we already figured out there was 5,280 feet in a mile. So you did what to figure out the total race in feet? Multiplied this by 3. So what is 5,280 times 3? 15,840 feet. Okay? So then if 6,000 of it was X to C, then what did you do? Subtracted 15,840 minus 6,000, and that gave you, and that's going to be the distance from C all the way to Y. But what did we know about the distance from C to D and D to Y? They're congruent. So what did you do to figure out just the distance between the two checkpoints, which was C to D? Divided it by 2. And so now you have this 9,840 divided by 2, which was 4,920 feet. Okay, here's a general rule for this class. On tests, you will have numbers that are pretty simple to work with. You might have some fractions and decimals, but they won't be crazy fractions like 15 over 343. They may be things like 3/4, okay? You're going to have some decimals and some fractions, but I won't give you large, giant numbers on a test with no calculator. On the homework, however, you may have some problems where the numbers are really big. If that happens, you have my permission to use a calculator for those problems at home, okay? Don't think that I expect you to spend an hour dividing or multiplying these really large, big numbers. That's not my intention, okay? If they're smaller numbers, you should try to practice them without a calculator to help you with that proficiency test and to prepare for the test. But if they're big numbers, by all means, you can grab a calculator, okay? We're not going to do the next example because it's just basically the same thing. Any questions about 1, 2? All right, then we're going to